So welcome back. We are now in the part two of the sheet, and in this section we are going to introduce objects. Now, what I'm hoping you will get from this video and from what we're attempting to do is a change, an approach to how to think about code. Initially, it'll seem like you're doing a lot of work. There is, let's put a point in here early, there is an overhead attached to this way of coding. And when you have small-scale projects, it can seem like the overhead isn't justified, but you have to bear with me. Because although there is an overhead involved with this, when we talk about objects and we code with objects, because it's very, very important how it works, it makes using code and writing programs like a jigsaw puzzle and actually really, really simple. Just so you appreciate that you've already been using this technology and this way of thinking without even realizing is, when you look at the line of code which does this, circle, and you pass it a whole bunch of stuff, this is connected to this object-based coding. Because what this thing is, and I will talk about this in the right time, is this is what's called a constructor. It constructs a circle using this information here. Keep that idea in your mind and that word in mind, because we will come back to that much later and you'll hear it echoed all the way through and the importance of it. What we have is behind this chunk of code, I'm going to find another color, is something called a class. Now, I'm only introducing these words so you understand what the crucial language is here. I'm not explaining what they are, but you have something called a class. And anyone who looked or peeked inside the graphics file would have looked and found this stuff, right? So what I'm trying to encourage you to think is, you, without realizing it, in order to use Python, you've already been using objects. What you haven't been doing is designing and creating your own objects. And that's the crucial element of this next section and this semester. Creating your own objects and then using them and testing them out. So in this video, what we're going to do is we are going to work through the stick figure. And it's a lot about thinking. It's a lot about how you change your thinking about this. So let's move on. So let's turn back to our stick figure, our infamous stick figure. Our stick figure is, to all extents and purposes, a single object. But the problem is that this procedural code, which uses stuff like draw, stick figure, and all this, treats it as a bunch of operations and parts. What I really want to do is try to treat it as a single block of organized code. So then if I want to move it, if I want to draw it, if I want to undraw it, if I want to change its color, as an object as a whole, I'm able to control that. Ideally, I am looking at trying to create code, right? Now bear with me. Oops, I seem to have pressed the wrong button. Bear with me. That I've got a stick figure and I can create it just like that. I can have a stick figure and I can draw the whole stick figure. And we'll talk about, where you're going to draw it and stuff like that. But more importantly, the bit I'm really interested in is I can get the whole stick figure and just ask it to move and give it some distance to move. And this code, this idea over here in blue, let's use a different color because blue may not be as visible, but this bit here about moving and asking the stick figure, calling something on the stick figure and saying, move yourself, here's a distance, right? That's really, really, really quite useful. Because then in essence, all of these different parts I have making up this, I don't have to worry about moving the head, moving the tail, moving the, no, it's not a tail, it's not a dog, moving the body, the arms. All I'm interested in is saying to the whole object, as an object, move. So you notice here that when I want to use it, what's really crucial is that I have a name of the object and I call something. I use this dot and I call something on this object. So there's the same object and I say draw, there's another one. Now that, if I set up the initial dimensions of my stick figure, if I construct a stick figure with certain dimensions, then suddenly I have, using this thing called object-based code or object-oriented code, it's often seen as OO programming, I can then suddenly treat this as a single object and get it to do really, really useful and simple things. So what I'd like to do is, and the problem that I've set out in the sheet sort of goes around this in a slightly upside down way. I'd like to be able to get some initial points, right? And we can use our get points function. For all of the code examples here, you'll find there are files that you can download and play. I can pass that in there, a window of some kind, okay? I can get the points, then I create a stick figure. I'm going to call it SF, not for science fiction, and I'm going to, just like the circle code, I'm going to say stick figure. I'm going to create you using those points. Now that's actually, I'm not drawing it in this line here. I'm not drawing it. I'm simply creating the object, and that is going to be my object. This code, to allow me to create, uses a very special type of code called the constructor. I don't know what I'm writing here. There we go, constructor, as I've mentioned in the previous slide, and we will linger on that in a minute. But essentially, let's go back. What I want to do then is I want to create the object, and then I want to do it like, I want to write code that looks like this, as we've said before. I want to, there's my object, it's SF, and I want something so I can then say draw. I might pass it a window, I might not. It depends how I want to organize my code. Okay, I might want to, and later on, I want to move the whole stick figure, and I can give it some new values, new distance and new Y. Now that is really, really quite powerful, because if I can use code, if I can build in the background something which will allow me just to create the object from a point, right, store it there, draw it, move it, then you suddenly start noticing, hang on, that could really, really be quite useful. I also at this stage want to just introduce, because lists are fundamental to this semester and this term, I want to say that I want to create a collection of stick figures, right? So I declare in the code, say a empty list. When I create my particular stick figure, right? And let's just write that example out, and there I'm passing it my values. I can then, for my collection, add my stick figure. Now I'm going to pause on this slide, because this is a seed concept that will work all the way through the semester. In the next week's worth of code, we go into this in much more detail. But look carefully at what we're trying to do here. I don't just want a single stick figure. I can create 100 of them, append them to a collection, which will store each of them. Then if I know the code to loop through this, if I want to move all of them or draw them in a slightly different position, I can do it using the collection looping code. So we'll come and look at that. What does that look like? Well, it's in your notes, but I will just give you a very quick reminder. It sort of looks like this. Item in the stick figure collection, ... and then you can do SF move or undraw. Now, what's the advantage of this and this concept here? We will come back to that later, but I want you to think that lists are going to play a very big part, both in Python and in Java. So let's go into the background of this code. In order for us to do it, what I would like to do is pause this video and start a fresh one and actually go through the writing of the code, because it's quite crucial and spending some time with it would be useful. So this is a good place to have a break.